Betsy makes $5 an hour for babysitting and $8 an hour for cleaning houses. Betsy wants to work a minimum of 10 hours per week. Graph a system of inequalities to illustrate how many hours Betsy needs to work at each job if she wants to earn at least $80 each week. Explain how to use the graph to determine the possible solutions. All right, we got a couple of things we want to grab out of here. $5 an hour for babysitting. $8 an hour for cleaning houses. And we want to make it up to at least $80 a week. All right. So my $5 an hour for babysitting, we'll go ahead and let babysitting be X and house cleaning be Y. So 5X plus my $8 times Y has got to be at least. That means it can't be any less than. It's got to be greater than or equal to 80. Betty wants to work a minimum of 10 hours per week. So it's going to be 10 or more. And so the babysitting plus the house cleaning hours must add up to 10 or more. All right, we have two equations now. Let's be able to graph them. It's going to be easiest to graph if they're in slope-intercept form. So on our bottom equation, let's see, x plus y is greater than or equal to 10. We'll subtract x from both sides. And y is greater than or equal to negative x plus 10. So my intercept is 10. It's going to be way up there. And we have a -1 slope. So we're coming down over 1. So we're going to go from corner to corner. All right, next equation. Let's simplify it down into slope-intercept form. 5x plus 8y is greater than or equal to 80. So we'll subtract 5x from both sides. Negative 5x plus 80 is greater than or equal to 8y. So we will divide by 8. And y is greater than or equal to negative 5x. Sorry, negative 5/8x plus 10. Notice negative 5 divided by 8, 80 divided by 8. All right, so we have the same y-intercept, we just have a different slope. We come down 1, 2, 3, 4, 5, over 1, 2, 3, 4, 5, 6, 7, 8. All right, now we want to represent our area of shading. Here it must be greater than, so above the lines. Here it must also be greater than, so above the line. Now notice the only spots where I'm going to have solutions that are above the lines are if they are above both lines. So that would be this entire area up here. Now, a couple of things we want to focus on this graph. We want to focus on the fact that you cannot have negative time. So we're not going to have any negative x values. We cannot have negative, I'm sorry, my x values are babysitting. We cannot have negative babysitting. We cannot have negative house cleaning. You can have no house cleaning and you can have no babysitting, but we can't have negatives of those. So if I do no babysitting, then I need to do at least 10 house cleanings. If I have no house cleanings, I need to do at least 5 babysittings. I can certainly do more than those. I can certainly do more than those. And then as we follow in the inequality statement, I need solutions that fall into this pink section in order to satisfy making a minimum of 10 hours and making a minimum of $80 each week. Question 15, write and solve a system of equations. The first equation passes through 1, 4, and 5, 8. The second equation has a slope of -2 and a y-intercept of 6. We're going to start with this one because that's already got the information we need. Y is equal to mx plus b. Well, we just determined that m is -2 and b is 6. And so we have an equation. Let's come to our other information. 1, 4, and 5, 8. We have 2 ordered pairs, so it probably makes sense for us to use our slope formula. M is equal to y2 minus y1 over x2 minus x1. So we'll label 1 as my first ordered pair, 1 is my second ordered pair. So that means I have an x and a y, an x and a y. My y2 is 8 minus my y1 is 4 over my x2 is 5 minus my x1 is 1. 8 minus 4 is 4. 5 minus 1 is 4. So we have a slope of 1. Well, now that we have a slope of 1, we need to know the y-intercept. So we're going to use our slope-intercept form. Y equals mx plus b. We'll plug in the values we know. Fortunately, we do know a y and an x because we're given those in the equation, and we do know an m, so we're only missing the b variable. So let's plug in some values. We have a y of 4 equals an m of 1 times an x of 1 plus b. 1 times 1 is 1. And we subtract 1 from both sides, and we get 3 equaling b. So our other equation is going to be y equals x plus 3. Now, I generally like them when we have 2 equations that are y equals, because that means we're saying that x plus 3 is equal to -2x plus 6. X plus 3 is equal to -2x plus 6. We will add 2x to both sides to make my x's positive, but also to isolate them to one side of the equation. So 3x plus 3 is equal to 6. We'll subtract 3. 3x is equal to 3, and so our x value is now equal to 1. Once we know the x value, we can plug it into either equation. Makes sense to use the one on the left because it's going to be much easier. If x is 1, 1 plus 3 gives me a y of 4. And so the solution to this system would be 1, 4. And we move on to the next problem. Number 16. Write and solve a system of equations. All right, we need to know what the equations are. I see a vertical line which tells me I have 1, 2, 3, and x equals -3 is going to be that equation. The second equation is a slanted line, so slope-intercept form seems to make the most sense. We have an ordered pair identified here. We have an intercept identified here, so it makes sense to start here and move up 1, 2, 3, and over 1, 2, 3. So our rise of 3, our run of 3, means we have a slope of 1. So I don't need to put a 1 in front of the x because we know that it is 1. And then I can see that the y-intercept is +2, so +2. Since we have already got a graph, we don't need anything to solve the system of equations. We can simply identify it by graphing. So the solution to this system of equations is -3, -1. Number 17, write a system of inequalities and name the solution. I see a horizontal line, which is a y equals equation. But notice that this horizontal line is dotted, which means I'm going to have a greater than or less than. And it's dotted but shaded below it, so we're going to have a y is less than statement. What value are my y's less than? My y's are less than 3. All right, let's go to the next equation. We have a slanted line, so we want slope-intercept form. I want to look to see where it's shaded. It is shaded below the line, which means, again, we're going to have a y is less than, but notice that this line is solid, so it's not just less than, it's less than or equal to. All right, we again want to find the slope, so we find an intersecting point, and we're going to be going down 2 over 2. So that will be a -1 slope, so negative x, we know to be -1 in front of x. And then the intercept here intercepts at 1, so +1. So we have the equation y is less than 3 and y is less than or equal to -x plus 1. Now our solution. Our solution here cannot be stated in terms of a single value like it could on the previous problem. Our solution is going to have to be identified by the graph, which it already is. Everything below the y is less than 3 line, and everything shaded to the left and below the y is less than or equal to -x minus 1. Number 18. For the function g of x is equal to x cubed minus 2x plus 1, find g of 4. Now remember, this means I'm going to take the 4 and I'm going to plug it in everywhere where I see an x. So g of 4 is equal to 4 cubed minus 2 times 4 plus 1. Now 4 cubed gives us 64. 4 times 2 is 8 plus 1. So 64 minus 8 plus 1, our g of 4 value is equal to 57. Now we could certainly list this as an ordered pair instead of a function solution. We could say 4, which is our x, 57, which is our y. Just another way of writing your outcome. Number 19, for the function h of x is equal to 3x minus 5, find x when h of x is equal to -23. So we're told that h of x is equal to -23. We're going to plug that in for the h of x. So -23 is equal to 3x minus 5, where we will add 5 first. So -18 is equal to 3x. We'll divide by 3, and x is equal to -6.